With verifying trigonometric identities, you're going to verify that it works for one value. One. Proof and verify are very different. Verifying just verifies that one value works, and yay, one value works. That's all you get. Proving, you're not going to plug in an actual value, you're going to leave it as variables, and you're going to prove that it works for everything, because you're going to leave variables, not put in numbers. So on the diploma and on unit tests, I might ask you to verify something for a specific value, or I might ask you to prove. But they are very different, and you have to follow the right format for each. So verifying trigonometric identity, this is for a specific angle. So you're verifying that something works for a specific angle, one angle, that is it. So for one angle, yay, left side equals right side. That's what verifying is. You know, you have been asked to check your whole lives, your solutions. You always check your solutions, put it into the left side and the right side and see if they equal. You've been asked to do that since junior high. When you solve for anything, you plug it back in, see if you get left side equals right side. That's verifying in trig. Instead of solving for an angle, what we actually just do is we give you one and you're supposed to verify for the left side equals the right side. That's it. That's all it is. So, there are the steps. We're going to go over here. Oh, here it says, when verifying, never cross over the equal sign. This is an electric fence, and you'll be zapped and hurt. Quite badly, I might add. This is no joke. You cannot cross over the equal sign. Remember when you guys check answers, you do left side, right side when you verify answers, and you don't move anything from the left side to the right side, right? You don't cross over the equal sign. You leave it how it is, and you verify straight down. Okay? Cannot cross over. You can't, like, add something over to the left or subtract something to the right. It's just left side by itself, right side by itself, see if they match. Okay? All right. So, how do we set these up? Everyone paying attention? It has to be done like this. So, I do t-tables. You can do equal signs, but I'm going to do a t-table first because most people prefer this way. So, I can short form only these two things in your entire math career. LS, RS. You can literally write LS and RS because in math books that represents left side and right side. There's your short form. Enjoy it. That's all you get. Those two. Okay? So LS represents left side. RS represents right side. Now when you go to do these questions, paying attention, your very first step of verifying is rewriting the left side and rewriting the right side with the angle in it. That's it. So I'm going to go, my left side is secant of, we're verifying that 60 degrees works for it. So secant of 60 degrees. And then tan of 60 degrees. Bless you. Divided by sine of 60 degrees. Your first step is to legitimately write it that way. So your first step is fill in the angle. Not really hard to do. People do it wrong all the time. Then off to the side, I'm going to find out what each of those values are. See, we're using chapter 4, right? That's all we're doing. We're using chapter 4. I'm going to go off to the side and find secant. I'm going to go off to the side and find tan. I'm going to go off to the side and find sine, and I'm going to plug them in. I'm using chapter 4. Because in chapter 4, you just find each of those separately, right? We're just going to now use them. That's it. So I'm going to go off to the side. I'm going to go secant theta. Instead of theta, it's secant of 60 degrees. What does secant go with, guys? Close. So what do we always have out? Our unit circle and our formula sheet. They are our best friends. If you have other best friends, you don't have to do that. Okay? Just your formula sheet and your unit circle. BFFs. So I go to 60 and I look at cos. What is cos of 60? 1/2. So what is secant of 60? 2. Because cos is cook extra rice, so secant would be rice extra, which is 2/1. Do we all agree with that statement? This is why chapter 4 is so important. If you can't do chapter So, then we have tan of 60. Tan is what divided by what? So we can use our unit circle. Yeah, sine 60 divided by cos of 60. What is sine at 60? Root 3 over 2. What's cos at 60? 1 over 2. So I get root 3 over, I don't know what I'm saying, root 3 over 2 times 2 over 1. And I get root 3. Cool. I have two things done. Sine of 60, do I have to, I'm going to write it off to the side because I like doing that. But you don't have to. Oh, you're running all over this. Sine of 60. We agree sine of 60 was root 3 over 2. Do we really need to write it over here? No. But I'm not a rebel, so I'm going to show all the work. Okay. So the first step is to fill in the 60s. Right? The second step is to now go and fill in your answers. That's it. This is like not crazy. I'm not even joking. Okay. Secant is 62 with an equal sign because secant 60 equals 2. Then this one is root 3 divided by root 3 over 2. What is, and I always write them sideways in their fractions, right? We've talked about this. Don't stack fractions. It makes your life harder. You can. You can stack fractions, the numerators cancel numerators, denominators cancel denominators. Sure, go ahead. It doesn't matter. I prefer flipping them. If you're someone who can cancel with them stacked, power to you. All right, if you can do it correctly. So, root 3 is over 1. So we get root 3 over 1 times 2 over root 3. And then we start getting really happy because we see what? They're going to cancel in matches. You know, Ariel? Oh, that's what's happening right now. Okay. So, our first step, fill in the 60s. Second step, go off to the side, figure out what they are. Third step, do some math, right? Fourth step, and you will lose marks if you don't do this, is you've just verified that that is 2 and that is 2, correct? So, at the very end, you have to write this. LS equals RS. You will lose marks if you don't verify, because that's the statement they're looking for at the end. They're looking for, okay, I verified it. How do I verify it? Left side equals right side. Yeah. No. Well, I would write it under your table because you don't want them searching for it. No.
Are you trying to find
No, you write it under. Because that's on the left side or right side. That's just a random LSRS off to the side of the page.
Okay, but they know what it stands for.
Why are you trusting that they possibly know what it stands for and assume that they won't lose marks on it? I do not allow anyone to take away part marks on me. When it comes to diploma, I'm like, oh, you want it under here? It's going to be, that is where I'm going to put it. Right here. Not a rebel. That is not the time to be a rebel. All right. Okay. Look at this one. Go. Okay. I feel like I talk to a brick wall sometimes, and right now you guys are going to do verifying okay because you haven't learned proofing. Once I show proofing, then you kind of like meld, and then both are wrong, which is a really bad mark on a test. Okay? So verifying, here are the steps. Ready? Step 1. These steps do not change. They cannot change. They're not allowed to change. You are proving that cotan x equals cos x over sine x with a pi over 6. That is what you are proving. That is what you, not proving, sorry. That is what you are verifying. It is what you are verifying, right? So your very first step is to rewrite it with an angle in it. So the left side and the right side, you have cotan of pi over 6. And the right side, you have cos of pi over 6 over sine of pi over 6. These are the easiest to mark on a diploma, or they're mainly the easiest. Either people completely screw it up right away and they replace it with something else, or they don't fill in the angle right away, or they fill in answers. I've watched some of you, you're doing this wrong. You're skipping this step. If you don't have this step on your paper, you're not proving this. I mean, you're not verifying this. You're trying to verify that cotan pi over 6 equals cos pi over 6 sine pi over 6. I'm seeing some of you just having the answers. You're not verifying anything if you don't have this. You need this step. This needs to be step 1. You cannot skip this step. You cannot change this step. This is why this is really easy to mark on a diploma. If this step doesn't exist, it's a 0. If this has been altered in any way with a pi over 6, it's a 0. If you just have work down here without this, it's a 0. That's why these are the easiest to mark, because they are often done poorly. They should not be done poorly. Step 1 is to verify that this plugged in for all the x's gets me the same thing, right? So your first step has to be to plug that in for all the x's, right? Second step is to get some answers for those things and just put it in. So cotan of pi over 6 equals cos of pi over 6, which is kind of what we're doing off to the side here, it doesn't matter, divided by sine of pi over 6. Cos of pi over 6 is root 3 over 2. Sine of pi over 6 is a half. So we get root 3 over 2 times 2 over 1, which is root 3. And then I go over here and I say this equals root 3. I've shown the work off to the side. Do you see that? The next one I have to physically show basically the work I showed off to the side. I now have to go cos of pi over 6, which is root 3 over 2, divided by sine of pi over 6, which is a half. Now I'm actually showing that math over here. Then I go equal to root 3 over 2 times 2 over 1. They cancel and I get root 3. Then I say LS equals RS. Some of you showed all this work but the very first step. How many marks are you getting? 0. You didn't verify anything. You just showed me some math. Although, albeit good math, it doesn't help. Verifying, you're verifying the equation. Does that make sense? That has to be stuck in your heads. Step 1 is essential, or 0 marks happen. It's the saddest thing ever. When you're marking it, you're like, 0, 0, oh, 0. So. Okay? This one, we are verifying that if I plug pi over 3 into this on the left side and pi over 3 into this on the right side, I get left side equals right side. So what is my very first step? Plug it in. Literally just write it. Like, don't give me any answers. I don't want any answers. Your very first step is to literally put pi over 3 in for the x's in your little table. That's it. Like left side, right side. So I'm going to go cotan squared pi over 3 plus 1. And then on the right side I have cosecant squared pi over 3. Do you see how I literally did nothing but put in pi over 3's? Right? I didn't change anything. I didn't go to my formula sheet and see that I can swap it out with the cosecant. That is proving. That is not. First step, fill in the pi over 3. Second step, go off to the side and find out what cotan of pi over 3 is and cosecant of pi over 3. Because we're going to be squaring those numbers. Right? So we go off to the side and we find cotan of pi over 3. Cotan of pi over 3 is cos of pi over 3 divided by sine of pi over 3. What is cos at 60 or pi over 3? Yeah. And what's sine at pi over 3? 3 over 2. So we get 1/2 times 2 over root 3. The 2's cancel. I'm left with 1 over root 3. Can I leave it like that? No, we'll always rationalize in 30. Times root 3, times root 3, and we get root 3 over 3. So, okay, I know cotan of pi over 3 is that. So I'm going to go, what does cotan squared of pi over 3 just mean? Yeah, cotan of pi over 3 squared. Remember, because that's how I have to type it in my calculator. There, you can't put the squared in the middle because the bracket pops open, right? So it just means that number, that answer I got, root 3 over 3 squared plus 1. Then I can square it, right? The squared has to go to both. So I get root 3 squared, which is 3, over 3 squared, which is 9, plus 1. 3 over 9 is a third plus 1. What's a third plus 1? 4 over 3. You can either type in your calculator and get the answer, or you can make common denominators. So it'd be 1 plus 3 over 3, so 4 over 3. Now we're hoping when we go to do the right side, we get 4 over 3. Right? That's our ultimate goal. So off to the side, I first have to find what? Cosecant of pi over 3. Cosecant is what flipped? Is the reciprocal of what? Sine, right? Cosecant is the reciprocal of sine. Reciprocal means flipped. So what is sine at pi over 3? So what's cosecant of pi over 3? 2 over root 3. And then we need to rationalize. Because cosecant is the reciprocal, which means flipped version. This equals 2 root 3 over 3 squared. Then I have to square everything. I have to square the, oops. I have to square the, oops. I have to square, what? I pressed red. I have to square the 2. I have to square the square root. I have to square the 3. I have to square everything. Just like in binomial theorem. So 2 squared is 4. Square root of 3 squared is 3 over 3, which is 12 over 3. Something is wrong with what I am doing. What am I? Oh, 9. 9. I didn't square the bottom. I didn't square the bottom. It's going to work. Yay, yay, yay. Woo, woo, woo. Nothing worse when you can't find your problem. But I found it. It's more than just the singing. It's the math. Okay, so I get 12 over 9, which reduces to 4 over 3, and they match, and I'm happy. And I was very sad a few seconds ago because if I square the 9, 3 to 9, then it wasn't going to match, then I was going to be sad. It was going to be bad. LS equals RS is essential. You seeing what I'm doing? Picking up what I'm laying down? First step, plug in just the pi over 3. Don't change anything. Don't go to your formula. Do not do any of that. I feel like I'm swimming. That first step has to be there. You cannot just put the answers. Yes? Like I see you all smiling at me and you're like, yeah, I totally get it. And then you go and you change it or you start writing the answers without doing the first step. It's like painful. Like you're like, yeah, I totally get it. And then you don't do it. It's just sad. Okay? Verify. And go. So, step 1, fill in. Don't change anything. Don't do anything. Step 1 should be like not rocket science at all. Step 1 is literally plugging the angle in. Step 2, go off to the side. Find out the math of the trig ratios. Step 3, be awesome. Yeah. Secant of pi over 4? Should be positive.
It would be after you like square.
It's a 3. It's a 3. Oh my gosh, I did not fill it in right. It has pi over 4 there. Do you see that? Yeah. Heavens to Betsy's. Oh my goodness. That's why I should not go watch a hockey game in the middle of a week. My oldness can't feel. There's negative, that's negative, that's negative, that's negative. Still works out. But whew, I would have gotten crap marks. By crap marks, I mean none. It would have been so bad. I would have cried. My emotions wouldn't have held together on that one. Been super sad about it. Just like when I was in grade 10 and I did slope. And I used the coordinate x1, x2, y1, y2 and filled that into the y2 minus y1 formula over x2 minus x1 formula. When we all know that coordinates are xy, not x1, x2. When you plug them in like that, you get 0. Not even like part marks. got my quiz back, and I was like, oh, it's so easy. Got my quiz back, and I got 0 because I did x1, x2, y1, y. Not cool. It was the worst of times. It wasn't even the best. There was no good. It was all bad. But guess what? Who's never ever put her x1, y1, x2, y2 wrong now? This cat. I learned my ways. Except I put not 3. Dummy. So there's 3 questions. That's it. There's not very many. There's very few. You need to, though, do this, and you need to be done up to 13, including 13 on the trig 1 review. We're going through it. This one here, that tandem, you're done for half, 3/4 plus, up to 13 and including 13. We're going through those tomorrow. If you still feel inclined to keep working on them, I would. I'm going to get the other half over the weekend. So if you have free time.